In how many ways can 12 gentlemen sit around a round table so that three specified gentlemen are always together? So let us consider A1, A2, A3, and so on, A9, A10, A11, A12 are the gentlemen. And since the three specified gentlemen are always together, let us assume that A10, A11, A12, they are always together. So let us put them in one box. And so the remaining A9, A1, so total 9, and here separate one box. Let us consider to be 1A. So total we can say there are 9 plus 1, 10 different things, 10 different or distinct objects. Now in a circular permutation or a round table, and these people A1, A2, and so on, A9, and again this A, and these things can be arranged. We know that if there are n different things, or we can simply write n distinct or different objects, can be arranged in a circular or round table in n minus 1 factorial ways. N minus 1 factorial ways we can say, because if in a round table, until and unless one object is fixed, we cannot fix the other. Suppose if A1 is fixed, then we have the remaining. So remaining means out of 10, 9 are there. So 9 things you have to arrange. So you can say so therefore required number of ways is equal to 10 minus 1, it's a 9 factorial, and again in within the box these three gentlemen can be arranged themselves in 3 factorial ways. So 9 factorial into 3 factorial, which is our option D. 3 factorial into 9 factorial is the answer. The number of ways in which the first, second, and third prizes can be distributed to or can be given to 5 competitors. So the competitors say C1, C2, C3, C4, and C5. And now, since they are competitors, each competitor will receive only one prize, either first prize, second prize, or third prize. And among these 5 competitors, only 3 of them may receive first, second, and third. So remaining 2 members may not receive also. So that you have to keep in mind. So first prize can be distributed to or can be given to any of the 5 competitors. So either C1 or C2 or C3 or C4 or C5. So this can be done in first prize distribution can be done in 5 ways. And now second prize can be distributed to any of the remaining 4, because if already one is selected, let us consider C2. C2 is already selected, got the first prize, let us assume that. Then remaining we have 4. So the second prize may be going to any of the four. So any of the remaining four competitors. So this can be done. So the second prize distribution can be done in four ways. Similarly, third prize can be distributed to any of the remaining three competitors. Let us assume that C1 is received the second prize. So the remaining three candidates are there. Among these three candidates may receive third prize. So it's not compulsory C1 and C2 are the prizes. It is just mentioned. So we can say third prize may received by the remaining three. So the number of ways is three ways. And hence we can conclude that total number of ways required is equal to, so first prize by 5 and second prize 4 and third prize 3. So we are using multiplication principle because and 5 into 4 into 3. So we have 60. So 60 is the answer, which is option B. How many different 9-digit numbers can be formed from the number 223355 triplet by rearranging its digits so that the odd digits occupy even positions? So let's take the 9 digit 1, 2, 3, 4, 5, 6, 7, 8, 9, and here we can say that the even positions are here. So total we have 4 boxes, 4 even positions are there, and remaining are odd positions, and given numbers 2, 2, 3, 3, 5, 5, 8, 8, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So given 9 digits, and these 9 digits to be arranged here in such a way that odd digits. So odd digits we have 3, 3, 5, 5, 4. 4 odd digits are there and 4 even boxes are there. So we have to put this 4 odd digits in this even boxes. So that can be done. So we can write the 4 odd digits can be filled in 4 even places. We can say even places as in. So total 4 are there. So 4 factorial, in which 3 is repeated 2 times. So 2 factorial, and 5 is also repeated 2 times. So 4 factorial upon 2 factorial 2 factorial ways, that is equal to, so 4 into 3 into 2 factorial upon, so 2 into 1 into 2 factorial. So we can say 6 ways. Similarly, then remaining we have even 1, 2, 3, 4, 5. So 5 remaining places are there. Now 5 even digits can be filled in the remaining 5 odd places. So this can be done in, so there are total 5 numbers are there. So we can say 2, 2, 8, 8, 8. So total 5 are there. So 5 factorial upon 2 is repeated 2 times and 8 is repeated 3 times. So this can be done 5 into 4 into 3 factorial upon, so 2 into 1 into 3 factorial. So we can say this is 10 ways. So finally we can give, therefore, required answer. since we have to occupy both odd digits and even digits to get a 9-digit number, so we need to complete these both works together. So we can say 6 ways and 10 ways. So 6 into 10, 60 ways. So we can go with an option C. So we need to count the number of times the digit 5 will return when listing the integers from 1 to 1000. Let us consider the single digit. In single digit we can mention like only one time 5 can be written. So we can say only one time. And when you are writing the 2-digit number, let us assume that one of the digit is 5. Let us consider to be tens place is 5 fixed, so that and ones place can be written among the 0 to 9 integer digits. There are 10 digits are there. Out of these 10 digits, already one time 5 is written. Let us assume that only one time 5 is taken. So remaining 9 can be taken. So 9 possibilities are there here. So 9 possibilities. And again, when 5 is taken in the ones place, and we may consider that, and here the tens place can be occupied by 0 cannot be occupied and 5 cannot be occupied. So among the 10, 8 possibilities are there. So we can write 8 possibilities in that case of 2 digit. It's a single digit repetition. Suppose let us take 2 digits are 5. So here we can say that it's only one possible way, but 2 digits are there. So 2. So for single digit and for 2 digits, we are getting the count 10 plus 10, 20. Up to here it is 20. Now let us consider for 3 digit. In the case of 3 digit, let us assume that only one time 5 is used, and that is considered here in the tens hundreds place. Then we have the possible numbers are among the 0 to 9, already 5 is fixed here. So out of 10, 1 is removed. So 9 possibilities. And here we may use 0 also. Here also 0 can be used. So 9 possibilities. So 9 into 9, 81 possibilities. That is 81 times 5 is repeated. Similarly, when 5 is taken in the tens place, so we can assume that the hundreds place 0 cannot be taken, 5 cannot be taken. So 8 possible ways. And ones place can be taken any of the digit other than 5. So 9 possibilities. So 9 into 8, 72. 72 times you will get this number. And when it comes to the a 3-digit number with the first units place is 5, it is fixed. And then once hundreds place 0 we cannot write and 5 cannot be taken. So 8 possibilities are there. And then middle number, that is a tens place, 0 can be taken, 5 cannot be taken. So total 9 possibilities. So 9 into 72 are there. So finally we can say here 81, 72 and 72 with a single digit. Only one time 5 appearing is 144. 144 plus 82, that is 226. Sorry, 225. 81. So 225 times with a single digit. Now let us assume that a 3-digit number with the 2 times 5 is there. Let us assume 5 is taken 2 times. Let us see hundreds place and tens place is occupied. So the remaining ones place we can write either 0 to 9, 10 digits excluding 5. So we can say 9 possibilities are there. and let us assume that first place and the last place is occupied. The middle possibilities are, again 0 can be included here also, so total 9 possibilities. And the next case, ones place and tens place is occupied by 5, but hundreds place, here 0 cannot be taken, so let us assume 0 and 5 are excluded, so total 8. So for 2 digit, 2 times 5, we can say 9 plus 9, 18 plus 8, 26. So 26 times possibilities are there, in each again 2 times is there, so 26 into 2, 52 times 5 is repeated. Now with the 3 digit, we can take only one time, but all the 3 5s are there. It is taken only one time, but all the 3 numbers are 5, so 3, we can say 3. So finally we can count the total number of 5s. Total number of times the digit 5 is appearing is 20 in single digit and 2 digit, and in 3 digits 225 plus again 52 plus again here 225 plus 52, and again here it is 3. So you can say 55 and 55, and here it is 20 plus 55, 75, 75 plus 225, which is equal to 300 and 300. And hence we can conclude that there are 300. The number of times the digit can be taken is 300. Option C. If summation r is equal to 0 to n minus 1 whole power r into ncr upon r plus 3 cr is equal to 3 upon a plus 3. So let us assume that n is equal to, let us solve by verification or substitution, put n is equal to 2. So we get the summation r is equal to 0 to 2 minus 1 whole power r into 2cr divided by r plus 3 cr, which can be taken as, first let us substitute r is equal to 0. So we'll get minus 1 to the power 0, 2c naught divided by 0 plus 3, that is 3c naught, plus minus 1 whole to the power of 1, 2c1 upon 1 plus 3, that is 4c, 2, 4c1, 4c1, and again plus minus 1 to the power of 2 into 2c2 divided by 2 plus 3, that is 5c2. So on simplification, we'll get minus 1 power 0 is 1 into 2c naught is 1 and 3c naught is 1. And here it is minus 1 into 2c1 is 2 and 4c1 is 4. And minus 1 whole square is plus 1 into 2c2 value is 1 upon 5c2 value can be taken as 5 factorial upon 5 minus 2, that is 3 factorial into 2 factorial, that is 5 into 4 into 3 factorial upon 3 factorial into 2 factorial. So we'll get 5 2s are 10. So on simplifying, so 1 minus here 2 upon 4 is 1 by 2. So 1 minus half plus 1 by 10 on simplifying. So 1 minus half is half, half plus 1 by 10, which is equal to, LCM is 10 here, 2 5 times, and here it is 1 time. So 5 plus 1, 6 upon 10. So 6 upon 10 we can write like 3 upon 5. So 3 upon 5 we can compare with 3 upon a plus 3. So we can say a plus 3 is equal to 5. So a is equal to 2. So we consider n is equal to 2 and a is we got a is equal to 2. So 2 minus 2 is 0. So we can go with an option A. Option A is the answer. Even you can check with any other value, n is equal to 1 also we can do it, or n is equal to 2, n is equal to 3, we can verify and we can check this. We need to find the number of values of r which satisfies the equation 39c3r minus 1 minus 39cr square is equal to 39cr square minus 1 minus 39c3r. So this equation can also be taken as 39c 3r minus 1 plus 39c 3r is equal to 39c r square minus 1 plus 39c r square. So by rearranging the terms here, and we know the property NCR plus NCR minus 1 is equal to n plus 1 CR. So here we can say that 39C3R and 39C3R minus 1, so that is 3 NCR minus 1, we can write 39 plus 1 CR is equal to 3R here, which is equal to, similarly here also 39 plus 1 NCR plus NCR minus 1, that is R square minus 1, so we can write 39 plus 1 C R square. So we can write it as 40C3R is equal to 40C R square. And also when NCA is equal to NCB, we can say either A is equal to B or N is equal to A plus B. So we can consider here 3R is equal to R square, or we can write R square plus 3R is equal to 40. So here R square is equal to 3R, or R square minus 3R is equal to 0. So R taken common, R minus 3 is equal to 0. So R is equal to 0 or R is equal to 3. And in the case of here R square plus 3R is equal to 40. So we can write R square plus 3R minus 40 is equal to 0. On factorization we can write 8R minus 3R minus 40 is equal to 0. So R taken common, R plus 8 minus 3 times of R plus, sorry, 5, so 8 minus 5, sorry. So minus 5 taken common here, R plus 8 is equal to 0. So we can say R minus 5 into R plus 8 is equal to 0. So which implies R is equal to negative 8, R is equal to 5. But according to the definition of NCR, your R must be greater than or equals to 0 and N must be greater than or equals to R. So here when R is equal to 0, so you're getting 3R minus 1 is less than 0. So which is not possible. So R is equal to 0 is not possible. So R cannot be equals to 0. And next, when R is equal to negative 8, 3 into negative 8, that is 3R, when R is equal to negative 8. So 3R is equal to minus 24, which is again less than 0. So R is equal to negative 8 is also not possible. So we can say R is not equals to negative 8. So the remaining R is equal to 3 and R is equal to 5, which are possible. So we can conclude that there are only two values which are possible, that is R is equal to 3 or R is equal to 5. So we can go with an option 2, only two values. In how many ways can a committee of 5 made out of 6 men and 4 women containing at least one woman? So we need committee with 5 members. So in which at least one woman is required, means so total 6 men and 4 women. So either we can have one woman, or we can have two women, or we can have three women, or we can have four women. So when one woman is selected, then to get committee of 5, so 4 men should be there. And when 2 women is selected, so we must have 3 men. And when 3 women is selected, we must have 2 men. And when 4 women is selected, so we must have 1 man. So that is one woman selection can be taken as out of 4 women, so 1 woman, so that is 4C1. And 4 men can be selected from 6 men, that is 6C4. Or we can say 2 women to be selected among 4. So here I can write 4, total 4 women and 6 men. So 4C2 into 6C3, or we can write 4C3 into 6C2, or we can write 4C4 into 6C1. So 4C1 value is 4 and 6C4 value 6 factorial by 6 minus 4, that is 2 factorial into 4 factorial, which is equal to 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial. So we can say 15. So here we can write 4 into 15 plus 4C2 factorial, that is 4 factorial by 2 factorial into 2 factorial, which is 4 into 3 into 2 factorial by 2 factorial into 2 factorial gets cancelled. So here we can say 6, and 63 factorial, we can 63 we can add 6 factorial by 3 minus factorial, 6 minus 3 factorial into 6 minus 3 factorial, that is 6 factorial into 5 into 4 into 3 factorial divided by 3 factorial into 6. So we can add 5 fours are 20, and again here 4C3 value is 4 we can write, because NC n minus 1 is n. 6C2 value is same as 6C4, so we can say 15, and 4C4 is 1 and 6C1 is 6. So 15 fours are we can write 60, and 26 are 120, and 15 fours are we can write 60, and again 1 6 are 6. So 120 plus 120, 240, and 6 246. So we can go with an option A. Option A is the answer. And here we can make a note, NCR is equal to n factorial by n minus r factorial into r factorial. And also we used NC naught is equal to NC n minus 1 is equal to NC naught is equal to NCN is equal to 1, and NC1 is equal to NCN minus 1 is equal to n. So which the calculation is based on these formulas. Okay, please note. All the words that can be formed using alphabets A, H, L, U and R are written in a dictionary order. No alphabet is repeated. Then find the rank of the word Rahul. So we need to find the rank of the word Rahul. Let us identify the positions. A comes first and H comes second, alphabetical order, and L comes 3, and then R, and then U is the 5. Now from the right side, left side, let us position R is the fourth position, A is the first position, H is the second position, and U is the fifth position, and L is the third position. We need to see the numbers which are to the left side of the letter or R. Less than 4, how many numbers are there? So less than 4, we have 1, 2 and 3. So there are 3 letters which are which are having position less than 4. Similarly, when it comes to the A, again you have to see the right side of A. Less than 1, there are no letters with whose position is less than 1, so 0. And for the H also, less than H, less than 2, there are no positions less than 2, so 0 and 5. And here we can see there is one letter whose position is less than 5, that is 3. So we can say, oh, there is one letter, and less than 3 there are no other things, we can write simply 0. And now coming from the right side, we have to start writing 0 factorial, 1 factorial, 2 factorial, 3 factorial and 4 factorial. So total 5 letters are there, we can write up to 4 factorial. Then we have to simplify by multiplying. So 3 into 4 factorial plus 0 into 3 factorial plus 0 into 2 factorial plus 1 into 1 factorial plus 0 into 0 factorial 4 factorial is 24. 24 into 3 and 0 here 0. 1 into 1 factorial is 1 plus 0 into 0 factorial is 0. So we can write 24 3 times 72 plus 1, which is 73. So there are 73 words before Rahul. 73 words are there before the word Rahul, and hence we can say the rank of the word Rahul as per dictionary order is, which is equal to 73 plus 1, that is 74. So 74th position, 74 rank, which is option D. The total number of 4-digit numbers in which the digits are in descending order. So there are 10 digits, 0 to 9. So by using this 10 digits, we have to select 4 digits, and it's a question is not about the number, like first unit digit of first place cannot be 0. So it is like only the number with 4 digit, any 4 digit number, like even we can take 0 1 2 3 also we can consider. So in such case, out of 10 digits, 4 digits to be selected, that is 10C4, and again these 4 digits can be rearranged in 4 factorial ways. So 10C4 into 4 factorial ways, it is the selection of the digits, selection and arrangement of digits. And now as per the condition, whatever the selection we made it, in which the order must be descending order, like an example 0 1 2 3, so it should be descending order, so 3 2 1 0. So this is only one way we can write out of 24, like 4 factorial possibilities. So out of 4 factorial possibilities, only one, that is 1 out of 4 factorial possibilities, we have one number. So 10C4 into 4 factorial, that is 1 upon 4 factorial into 10C4 into 4 factorial is according to the given condition in a descending order arrangement. So we can say 10C4 is the answer, which is option B. The number of all 3 element subsets of the set A1, A2, A3 and so on up to AN, which contains AN A3s. So we need 3 element subset, like an example A1, A2, A3 is one subset, A2, A3, A4 is another subset. Like a 3 element subset is required with the condition that which is always containing A3. Which is always containing A3 means among this A3 is already fixed. Now we need to select only 2 elements among the remaining elements. So when A3 is selected, so remaining elements are n minus 1. Now among these n minus 1 elements, we want only 2 elements to be selected. So that can be taken as n minus 1 C2. So n minus 1 C2 will be the answer, which is our option C.